Great. Well, we're here today with Middleborough Gas and Electric Department and Abode Energy Management. The subject of this webinar is Air Source Heat Pumps 101. So we'll be talking about heat pump technology as well as the programs that Middleborough is offering to its customers to help install and explore these technologies. Here from Abode, we have Mike Simons and myself, Ryan Keith. We also have Kyle Holmberg and Annie Taylor from Middleborough Gas and Electric Department. Next slide, please, Mike. Great. So like I mentioned, this is being recorded and there is a question and answer feature as well. So if you'd like to type in any questions throughout the course of the webinar, I think we will be touching on a lot as we go through, but don't hesitate to put in any questions. Things that we can answer in the chat, we'll answer in the chat. Otherwise, we'll save larger questions for the end. And if you are calling in by phone, you can enter *9 to raise your hand throughout the course of the webinar, especially towards the end once we open up for question and answer. Next slide, please. Great. So just a little bit on the program and the motivations here. So this is really a resident-oriented program. Each house is different and each heat pump system is different. So we want to understand your specific goals for your project, the configuration of your home, and what types of heat pumps will or won't work for you. So we primarily offer that in the form of a consulting service. It's a no-cost consultation that we offer where we can really speak with you, learn about your goals and the specifics of your home, and then help start thinking about what types of heat pumps would be best suited for you and for your project goals. Next slide, please. Great. And just some big picture to help contextualize this program and heat pumps as a whole. So we really need to lower the amount of carbon emissions that we're putting into the atmosphere. Those carbon emissions are contributing to climate change and a whole host of adverse impacts. So the way that we're doing that in this scope of work, in this residential energy efficiency realm, is through energy specialists who are looking at homes and thinking about areas where energy usage can be cut down and made more efficient. There are certain technological advances, specifically in the HVAC world, that have made heat pumps ready and effective to be used in cold climates in the Northeast, which is not wasn't the case some years ago, but now they are market ready and highly effective to be used in this climate. But you do have to be very specific about the equipment that you're selecting and how it's being configured in the home in order for it to actually achieve those goals and those energy savings. And that's where this program really comes into play. Next slide, please. Mike, I'll let you take it over from here.
All right, perfect. Well, thanks for everyone for attending. It's a pleasure to speak with you, and I look forward particularly to the question and answer section at the end. So any questions that you do have about heat pumps, please put them in the chat and I'll be happy to tackle them before this evening concludes. So I wanted to start with this, and it's a little bit of a bummer, but I wanted to answer kind of some market objections that the Boston Globe reported last year. So the Globe ran a real good series about heat pumps and electrification. And one of the things that they were saying is that the state is falling really short regarding kind of the goals that it needs to meet for 2030 to lead us into 2050 for us to hit our climate goals and stay on the roadmap. And so some of the highlights I thought in the article were this. It's like some homeowners said contractors affiliated with Mass Save dissuaded them from removing their fossil fuel system. And then there's another quote where it's like some residents said that they sought to convert their home off of fossil fuels, but contractors told them that heat pumps could not adequately heat throughout a Massachusetts winter. And the last one was, it was an anecdote about someone trying to adopt whole home cold climate heat pumps and said out of 5 contractors he spoke with, only 1 was comfortable converting the home off of fossil fuels and onto heat pumps. So one of the goals with the webinar is just to try to clarify like maybe a little bit of the history of this and help people understand exactly how the technology is actually going to be performing in homes today. So here's key concept, I think, number 1. So I don't know off the top of my head if Middleborough and Lakeville's design temperature is 2 degrees or 10 degrees or 12 degrees. But fundamentally, when you're trying to design an HVAC system, you're trying to move the home from the design temperature, which is like the coldest day of the year, all the way up to 70 degrees. And if we were to look at these three homes at the top, one of the home, I'll call it the leaky farmhouse, needs 100,000 BTUs per hour to go from, say, 2 degrees outside and constantly maintain a temperature of 70 degrees. And the highly efficient looking home on the right-hand side, instead of needing 100,000 BTUs, that home is only going to need, say, like 24,000 BTUs per hour. So core concept number one is different homes need a different amount of energy introduced per hour, depending on how leaky and inefficient the home is. So let's now look at the bottom of the slide. So on the bottom of the slide, I have two different types of heat pumps. One is a traditional heat pump and one is a cold climate heat pump. And the difference between the two is if we are to look at the performance of a traditional heat pump, say at 47 degrees outside, that heat pump can introduce 30,000 BTUs per hour to the home. But at 5 degrees, that heat pump can only put out 12,000 BTUs per hour. So if I were to try and heat up this leaky farmhouse with this non-cold climate heat pump, I would need 9 outdoor units to just power that house to just make up for the amount of energy that it's losing. If I'm looking at the heat pump on the bottom right-hand side, I would see that this heat pump, no matter if it's single digits or if it's 47 degrees outside, it can still supply 30,000 BTUs per hour. So with the leaky farmhouse, for example, maybe I would be able to get by with 3 heat pumps or 4 heat pumps to power this really leaky, inefficient home. One of the things that's really important as we are thinking about heat pumps and adopting it, there's really no reason why this leaky farmhouse is always going to need to stay as a leaky farmhouse. The walls can get insulated, the windows can get replaced, the attic can get air sealed and insulated. So these are all going to be types of measures that I think would be just as important with trying to adopt as it is adopting air source heat pumps, particularly cold climate air source heat pumps. So I can speak a little bit to this because this is actually my house. So when I bought my home a little over a year and a half ago, when I did buy it, I ran what's called a manual J heat load calculation. And that's what informed how leaky my home was or how big of a heating system I needed to buy. So when I was looking and doing the manual J heat load calculation, I put in my uninsulated walls, my single pane windows, my leaky attic, and it ended up putting out a number of my home needing 108,589 BTUs per hour. And then when I went down into my basement and I looked at my steam heating system and I looked at what the output of that steam heating system was, it was 129,000 BTUs per hour. So 129's bigger than 108. My steam heating system was properly designed. It had enough horsepower or enough heating capacity to be able to surpass my heat load. Now, I didn't stop there. What I did was I fully insulated my home. So I insulated my walls, I insulated my attic, I air sealed the heck out of everything. I'm still trying to air seal the house even more. I replaced all my inefficient windows for Energy Star windows. And after I did all of those measures, this is how my home ended up looking. So instead of needing over 100,000 BTUs, now I needed 47,000 BTUs. And if I were to look at heat pump equipment on the market, here's a piece of equipment on the middle of the screen. This one piece of equipment can support up to 8 indoor units. And if I were to look at its max heating capacity at 5 degrees, this one heat pump can put out 54,000 BTUs per hour. 54,000 BTUs per hour is greater than what my home needs. This type of equipment will work to 100% displace the need for me to ever run that steam boiler ever again. So as far as key concepts with adopting air source heat pumps, Just know you can use them to heat up a leaky farmhouse, but you can also use them to heat up an averagely performing home. The other key takeaways that I think are so important. Say if I did just put in air source heat pumps into my home as it was performing, I have to estimate my operating cost if I didn't do anything and I did adopt the heat pumps to be somewhere around $32,000 per year. It would have been really expensive to heat. Instead, my heating expenditures, and I have much higher electric rates than you guys do, is about $1,600. The install cost of putting in one properly sized air source heat pump for my home, say each mini split is roughly $5,000-ish, 4,000 to 5,000 in my case. So it changed the install cost from what I paid as 22,000. If I didn't do any of those weatherization improvements, then it would have been somewhere closer to like $40,000 or $50,000. So do know that like there's a direct correlation with like install cost as well as operating cost with adopting air source heat pumps in a well buttoned up home. And the last thing that I think is really important is, say if you are putting on, say, 2 large outdoor units because you do have a massive heat load still, each of the outdoor units is going to be taking up real space in your main electrical panel. And we have a lot of things to decarbonize and a lot of things to electrify. And if you are just chewing up all the capacity in your main electrical panel with air source heat pumps, you're not leaving space for, say, decarbonizing your transportation or your domestic hot water or putting in an induction cooktop. So that's another thing that I think is important to be keeping in mind.
And Mike, before we move on,
Yep.
The heating BTU calculator, is that a tool that our customers would have access to, or is that something that a boat would handle?
Yeah, so with doing an accurate manual J heat load calculation, it really is up to the HVAC contractor to be doing, because they're going to be the ones who are sizing the equipment and kind of going to be the ones who are guaranteeing that it will work. It does make sense to be on site when you are gathering up all of the measurements on it, because it is really hard virtually to know what's in your walls, what's in your attic. So that responsibility is really on the HVAC contractor. Some of the more reputable ones, what they'll do, it takes time to do this calculation. Some of them will say it'll cost $500 or $700 to do a manual J heat load calculation, but we'll take whatever that payment is off of the final total if you go with us, if you commission the equipment. If you do need someone to do it as a third party, a HERS rater is typically someone who has the capability of doing this accurately. And then another resource, there's a free software online called Cool Calc. And you are able to generate, the report for free. So if you are somewhat technically minded and nerdy, I would recommend heading over to coolcalc.com and playing around with the software yourself. It has a pretty low learning curve. So I do think that's a potential resource as well.
Okay, and we also did receive a question in the chat. Well, we're on the topic of weatherization. Somebody asked, for new construction, what insulation do you suggest? I don't know if that's something we could speak to.
Yeah, the only thing that I can touch on with that real quick is, so we do talk about carbon, and most of the time when we're talking about carbon, it's about operating carbon. It's about homes using less energy. And it's not necessarily taking a holistic approach with thinking about how much carbon went into making certain building materials. So if you are just solely focused on operational carbon, closed cell spray foam, isonine is likely the way to go. If you are kind of thinking slightly more holistically about the entire project, wood is good, and kind of the cheapest, most effective wood-based insulation product is cellulose insulation. So that would be kind of the 2 comments that I'd have on that.
Great, thank you. So, and I just shared the link for the CoolCalc DIY calculator. This technology seems pretty complicated. So we're wondering, how do they work?
Perfect. Thanks for the question, Kyle. A heat pump works the exact same way that your refrigerator does, is the easiest way to explain it. So inside of your refrigerator, what is happening inside there is there's heat inside of the box, and the refrigerator takes that heat and takes that energy and it puts it outside of the box into your kitchen. So it's just using a refrigeration process to move energy from one location to another. Heat pumps work the exact same way. So let's just say hypothetically, it's 0 degrees outside. 0 degrees is very cold, but it's not nearly as cold as -30 degrees. So that informs to me that even at 0 degrees, there's a lot of energy in the outside air because it's warmer than -30 degrees. So how a heat pump's gonna work is it's gonna say, take refrigerant that could be -30 degrees, and it's gonna bring that refrigerant outside. -30 is colder than 0, and hot goes to cold. So that 0 degree air is gonna pass over this -30 degree refrigerant until the refrigerant's no longer -30, but it's gonna warm up. It's gonna be -2 degrees or -4 degrees. And then as it's about to head back inside, it's going to pass over a contraption called a compressor. And one thing that's true with physics is if you increase pressure, you're going to increase temperature. And if you're going to decrease pressure, you're going to decrease temperature. And an example and an anecdote of that is, say if you take a can of compressed air and you release the pressure, the can becomes cold. Decrease pressure, decrease temperature. But over here, it's going to compress it. It's going to increase the pressure, and it's going to increase the temperature, and it's going to make it really hot. And by really hot, I mean like 80 degrees or 90 degrees. And now you have 90 degree refrigerant coming into the home. 70 degree air or 69 degree air is going to pass over this 90 degree refrigerant. And now the air is going to be 70 degrees or 71 degrees or whatever you set the thermostat to. And now this refrigerant's slightly warm, it's slightly less hot, it goes back outside, they completely drop the pressure, it becomes wicked cold again, like -30 degrees. And this process just happens over and over and over again. And if the system's right size, it's just really literally humming along all fall, all winter, all spring, whenever you're calling for heat. So that's how it works on a technical level. If I was a sales consultant, I would say a heat pump works great. It works better than you can ever imagine. But that's kind of the fundamentals of how a heat pump works. And heat pumps, they have heat in the name, but it's also a central AC. So just in summertime, there's a reversing valve. It just takes heat from inside the home and it spits it outside the home. The other thing that I'll just highlight too, while we have this slide up, is on the right-hand side, we see some components of a air source heat pump system. One is the outdoor unit and one is the indoor unit. And it's just going to be refrigerant flowing between those two different locations. And it's going to just get the inside whatever temperature you want it to be. So it's called ductless because there's no ductwork on this mini split. It's called ductless. The mini is that usually the capacity of this equipment is much smaller, and it's called a split unit because the indoor unit and the outdoor unit are not packaged together like they would be on a window air conditioner or a refrigerator. So they're split apart. So that's how heat pumps work.
A question we receive a lot is just how green are heat pumps?
Yeah. So it 100% depends on your electric grid, on how dirty the grid is or how clean it is. But the good news in Massachusetts is we've retired all of our coal-fired power plants. There's pretty much hardly ever any petroleum-fired power plants. So when we are thinking about our grid mix, there's a lot of natural gas going into it. There's still a good chunk that's nuclear. And then there's renewables, and the renewables is growing every single year. So if you were just using electricity for heat, like as a toaster oven or as a blow dryer, air source heat pump, electricity isn't necessarily green per se, but with heat pumps, you're using that electricity to just move heat from one location to another. And that is going to use like 2.5 to 3 times less electricity than just generating heat. So in Massachusetts, our grid isn't necessarily green, but it's getting greener. With heat pump technology, with just using electricity to move heat, everything turns out much more favorable. So we have kind of a chart that shows with the average size home, how many tons of CO2 emissions is released by all the different fuel sources. Yeah, and it's always going to be cleaner in Massachusetts to be heating with a heat pump than it is with burning gas, burning petroleum, or burning propane. And the last thing that I will also comment on is with Middleborough Gas and Electric Department, they have really great solar policies as well that supports full retail net metering. So if you are adopting on-site renewables, then as far as the carbon emissions go, different people have different definitions of net zero, but putting heat pumps with renewables, it really does become in some ways like, I know it's all buying equipment and buying hardware, but it really can become like a no-brainer if you really are trying to reduce your emissions as close to zero as possible.
The question on everyone's mind, does this equipment work in freezing temperatures?
Yes, so I do think that I did somewhat highlight this at the beginning with just pointing out, as long as you're selecting cold climate heat pumps that don't have a capacity drop, there is no problem with air source heat pumps heating 100% of the year with freezing temperatures. So here is something that we did put together that is kind of interesting to look at. And we've pulled this like data for like Fargo, North Dakota, and Juneau, Alaska, and it's a wildly different story over in those locations. But when we're looking at Massachusetts and we're looking at what number of hours we spend at different temperatures over the course of the heating season, we will see that the vast majority of hours are really spent even above freezing. So thought number one, if you do have a traditional heat pump, like not a cold climate heat pump, it doesn't sting by any means. Like you're still good to go for likely say firm freezing all the way up to 69 degrees. But with the cold climate heat pumps, do know that they are able to maintain 100% of their capacity over into this range. So like 0 to 5 degrees, different manufacturers have different ones on when they do start to have a capacity drop. It's not until sub-zero temperatures that there is any sort of capacity drop. So say, for example, that 3-ton heat pump, if it is negative 15 degrees outside, instead of it being a 3-ton heat pump, it's probably like a 2.5-ton heat pump. And one of the things you may be asking yourself, it's like, well, if I needed 3 tons, but it's only 2.5 tons and it's negative 15 degrees outside, like what happens? And the answer is nothing catastrophic. The heat pump's still introducing 2.5 tons worth of energy into your home. So maybe instead of being able to keep it at 70 degrees when it's negative 15 degrees outside, maybe it's only going to be able to heat it up to 64 degrees or 63 degrees. Nothing weird happens. And also one of the things is like with these negative, like severe sub-zero temperatures, they have happened. Like when I did pull the data, there was a negative 15 degree hour outside, but it's not really like part of our climate reality to be so worried about. What I would be more worried about with thinking about climate and thinking about weather is the fact that right now we have about 9 days over 90 over the course of the summer. By 2050, they're saying that we're going to have about 29 days over 90 over the course of the summer. So that's really where like my attention is focused upon, is not these sub-zero temperatures in performance, but just making sure that everyone has like a safe place to live over the course of the summer.
Another question and thought is on everyone's mind is heating with electricity must be expensive.
Yeah, so, and I goofed over here because I should have put in Middleborough's rates, because right now what I have on here is the investor-owned utility. So I have National Grid's rates on here, but do know, I can't say this enough, your electric and gas department have done a phenomenal job of making electricity affordable. So I pay close to 30 cents per kilowatt. You're paying closer to 20 cents per kilowatt. So do know that the actual rates on here should be a bit lower than what's being presented. But over here, we're still kind of looking at the same type of chart. So we're seeing all of the different temperature outside, but now we're just going to go and look at all of the different fuels. So with electric resistance, so that's just using electricity to generate heat the same way your toaster oven or blow dryer would use it. And we're looking at, say, like the peak, you know, this is $250. And if we're looking at the next line down, that's propane, and that's about $200 for this like 1 degree over the course of the heating season. And then we slide down a little bit more, that's home heating oil. And then we slide down and we see this green line, and that's how much it'd be costing with air source heat pumps if the system is properly designed. So it's cheaper than home heating oil. It's a little bit more expensive than natural gas, but it is, you know, it's predictable, it's affordable. With electric prices, they never have these massive swings up and down like home heating oil in particular right now. So yeah, just it's using electricity to move heat, and it works out for our climate, and it works out especially for you guys with your extremely great electric rates.
So heat pumps can't be perfect, right? They must be loud or something.
Yeah, and I'll add more nuance to this than this slide is going to cover. So over here with air source heat pumps, the outdoor units are hovering in the 40 to 50 decibel range, which you'll see it's somewhere between like refrigerator and rain and slightly underneath someone chatting. Few key concepts over here. Not all cold climate air source heat pumps are this quiet. The quiet ones are typically from the Asian manufacturers. So Mitsubishi, Fujitsu, Daikin, LG, Haier, Samsung. There's a handful of these Asian manufacturers that have the heat pumps that like have the fan that's blowing out the side. Those units are the wicked quiet ones outside. There's other manufacturers, let's say, typically a lot of them would be American or European, and their heat pumps are typically advertised as low as 70 decibels. And it's not necessarily fair or good marketing to say like as low as 70 decibels. It'd be like my children could talk as low as 30 decibels, but they rarely are that quiet. So that's something to keep in mind, is do make sure that you are looking at the specs. The other thing to keep in mind regarding the noise of the units, the indoor units on ductless equipment are super quiet when they're just humming along. But I would, as far as a heat pump consultant and someone who's lived with this equipment, I would just make a note, do not stick any ductless mini split directly above your bed. Just because at 2 a.m., if there is like a refrigerant processes happening inside of the unit, and when it's, you know, completely quiet in a bedroom and it's right above your head, like you may be hearing that. So they do make some noise. They're really quiet. So yeah, I think those are some of the nuances regarding noise with the equipment.
But what if I'm skeptical that a heat pump will work in my home?
Yeah, so let me go back with say there is times with the consultations that we may express skepticism as well that heat pumps are going to be perfect for your home based off of what your goals are and budget. So there is sometimes some nuance regarding kind of like interior design decisions, architectural decisions, the reality of a budget and how much equipment that can get you. So do know that sometimes with being skeptical with a heat pump will work in the home, there is sometimes there is occasion where maybe an air source heat pump is not the right choice. However, some things to be thinking about with air source heat pumps, with thinking about carbon, with thinking about comfort, is there's a lot of different options that may work. So most people, when they're thinking about heat pumps or ductless mini splits, they are thinking about really this combination, like a unit outside and a unit hanging on the wall. There's also equipment that would look like this. So there's a unit outside and maybe 2 units hanging on the wall off of it, but there's also this unit down here, and that's called a ducted mini split. So instead of say having 2 of those units on the wall for 2 separate bedrooms or a living room and a kitchen, you could just have 1 unit down in the basement, and that could be coming up, and it could be conditioning 1 room or 2 rooms or 3 rooms or 4 rooms all through ductwork, the same way a gas furnace or an oil-fired furnace or a propane furnace would. So there is a lot of flexibility with design. Some other things regarding kind of design, and maybe if someone doesn't want a wall hung unit, I do think that a great option is a floor mounted unit. Particularly in first floors, you can just come up through the basement and then you can put this type of equipment on interior walls or on exterior walls, and then you don't have the line set visible from the outside kind of coming down the house. So that could be an elegant option. Another option for adopting heat pumps could be recessed ceiling cassettes. For retrofits or existing homes, these really make more sense when there's an unfinished attic space above you, but for new construction, this certainly could be a first floor or second floor type of equipment that could work. And then with going back to the ducted mini splits, handful of different options. So if you're just trying to condition 1 or 2 rooms, you can just have a slim duct unit. If you're trying to condition an entire floor, they have these units, which are called medium static units. They have a bit stronger of a blower and have typically a bit more heating and cooling capacity. And lastly, we have a centrally ducted system. So this is a 1-for-1 swap of a oil-fired or propane or gas-fired furnace, but this is just going to be a centralized heat pump. And one of the nice things about centralized heat pumps as well is you can build in a little bit of redundancy with the equipment. So this type of equipment, if the outdoor unit is covered in snow or there is a snow apocalypse or a polar vortex or any like weird weather event, this can also have an electric resistant element that can kick in during those super extreme weather events. So a lot of flexibility regarding design. Wall mounts, floor mounts, ceiling mounts, or just going with ducted. There's usually a way to adopt air source heat pumps.
So Mike, what if our customers have some large rooms in their home?
Yeah, so with large rooms, so a few things to keep in mind. With ductless mini splits, they start around 6,000 BTUs per hour, which is like the same type of capacity as a window air conditioner would be. Like the smallest window air conditioner, they have ductless mini splits that are also that small. But on the residential side, those units go up from like 6,000 BTUs all the way up to 24,000 BTUs. So small room or large room, there is likely a good opportunity that there will be a mini split type of equipment that could work for it. But I did want to highlight some equipment selection nuances over here. So if there's anyone on the webinar right now that's heating with a wood stove or a pellet stove all winter long, you may be totally fine with that, where the room that it's in is delightful. Maybe it's a little too hot sometimes. And the further away you drift from that unit in the house, the colder it's going to be. And for a lot of people, that's perfectly fine, that the living room say 70 degrees and the bedroom 62 degrees. I just go into my bedroom to sleep. I like it cooler when I sleep. This setup can work perfectly fine. But for a lot of people who may have grown really accustomed to central HVAC systems, this may not be enough emitters or units to be comfortable. So let me just put this as a concept. This zone or this condo needs 18,000 BTUs. This unit is providing 18,000 BTUs. Everything checks out with me. Let's look at what happens over here. I said the smallest mini split was 6,000 BTUs. The load here is still the load is still 18,000 BTUs. But now we have 1, 2, 3, 4 mini splits. Each is requiring 6,000 BTUs. On paper, I'm thinking that this is a little bit oversized because it's like a 24,000 BTU worth of heat, 18,000 BTUs that's needed. It's a little oversized, but everything's going to check out. One of the things that we deal with as heat pump consultants is if you put 4 units on one outdoor unit, the smallest outdoor unit that supports it is 36,000 BTUs. The load's 18, this is providing 36. It's 2x oversized, and that becomes slightly what we would call like risky as far as performance goes. So that's a concern that we have with like, maybe it's not going to save us much money. Maybe it's going to not do as an effective job with removing moisture in the summertime when it's cooling. So we do run into problems with people oversizing, and this could be contractor related or it could be what the customer is asking the contractor to do, with just putting in too much units and having too little flexibility in the design. So that's a reality that we're concerned with. Instead, what we would propose for people to do is something like this. It still needs 18,000 BTUs, but now they have, say, a 9,000 BTU ductless unit covering the main area, and then say over on this side of the house, another 9,000 BTU ducted unit, and off of a medium static unit, now you could even add a separate emitter into the bathroom. So we are very conscientious about design. If I had one thing that I think we do a better job, we really add a lot of value in the consulting process, is just making sure that the heat pump system is is well designed and will be meeting your goals. The last thing I didn't talk about is, out of all 3 of these systems, the most expensive one, this one, is probably going to perform the worst. So there is likely going to be a install cost savings with getting a right size system versus buying an oversized system that will work inefficiently.
Another very common question we get, are we, MGED, rebating this equipment?
Yes, you are. So with, let me actually start here and then we'll flip it back. So what is, in my mind, what's really great with your program is the rebates are generous. It's $500 per ton up to $2,000. And the requirements that are put into place is ensuring that high performing heat pump equipment is installed, and your requirements are quite good and generous. A few nuances with the program is, so Abode, the company that I work for, we have a participating contractor list. The contractors that are participating in it understand the rebate process, the pre-approval, the post-quality assurance that's required. If you are wanting to work with your own contractor who is not on the participating contractor list, more than welcome to work with whoever you want, as long as they play by the same rules and install energy efficient equipment, and they go through the same pre-approval process and the post QA process. The other thing that is on here that I do want to touch on as well, as far as I guess benefits of consultation, is and this is something that we always send to everyone, but I wanted to, at the conclusion of the consultation, but I wanted to highlight it here. If you are wanting to explore heat pump technology and get a really good understanding of like what as a homeowner you should be looking for and asking for, and how you should be thinking about it, this document, which is called the Northeast Energy Efficiency Partnership Air Source Heat Pump Consumer Buying Guide, is a really good place to start. So if there's a QR code, if anyone wants to quickly scan it, or Kyle, if you want to maybe just put it in the chat as well, it'd be a great place, a great next to do after watching this webinar. And then the last thing that I'll say is it's like a 15-page document, but the last page on it is a list of questions to ask any heat pump contractor. And I do wish, even for my own heat pump project, that I asked some of these questions, because it would have made the install a little bit smoother. And so one other thing regarding what's happening right now is, if you did want to get on the calendar to talk in depth about your home and your heat pump project, if you do head over to abode.energy/consultations, or sorry, consultation, that would be how you can book some time directly onto my or one of my colleagues' calendar, and we can start thinking critically about your home and your project.
Mike, I'm happy to speak about this if you want me to take things over.
Certainly.
Great. So some related programs, and we've touched on some of these as well, that Middleborough Gas and Electric Department offers around decarbonizing and electrifying your home. Great first step is to get a home energy assessment. That's provided at no cost through Energy New England. That's another provider. They will currently, the offering is virtual in non-COVID times. It would be someone coming out to your house, but they'll take a look all throughout your home, identify areas for improvement, and whether maybe heat pumps are a good option, maybe solar is a good option, and then can provide you with a report about your home's performance and connect you with resources for next steps. So getting a home energy assessment done as a first step is a great place to start. Middleborough also offers services around weatherizing and solar. So in the same way that we offer consulting services on heat pumps, Abode is also offering consulting services on weatherization and on solar PV. So like we mentioned, starting with efficiency first, weatherizing your home, air sealing your home, reducing your home's heating and cooling load is going to reduce the cost of installing heat pump equipment. It's going to reduce your operating costs of heat pump equipment, and it's going to improve your comfort throughout the year, both for heating and cooling. And then also installing solar PV, or solar panels, as you may know it. Like Mike mentioned, that will make your heat pumps more efficient, rather than using electricity that's, generated using gas and oil and coal somewhere else. You'll be using electricity that's generated right on site, just from the power of the sun. So your heat pumps will be super efficient, super green. And also you'll be reducing your costs of operation for operating the heat pumps, because you won't need to be buying that electricity. You'll just be generating it right at your own home. So these are all good things to be thinking about in tandem, and Abode and MGED do offer services around these technologies and improvements as well. Next slide, please. Great, and here's just some contact information. We can keep this up during the Q&A, which will be starting momentarily. But if you would like to schedule your consultation or take a look at either our websites or MGEDs to learn more about the rebates, those are there. And then also some of the resources that we touched on throughout the course of this presentation. And just to reiterate, we will be sending around the webinar recording to anyone who is registered along with the slide deck. So rather than having to copy down all of these URLs yourself, you'll just be able to click into them once you have the slide deck.
So I think now we can move into the Q&A. So thank you to everyone that submitted questions leading up to the webinar. Brian, do you want me to read them off and then you and Mike can answer them?
Sure, sounds good.
So someone asked, are there local companies with a proven history of installations?
I can take that one. Yes. So we do have the participating contractor list. Like Mike mentioned, that's not an exclusive list. You're not required to work with someone on that list. So for example, if you have a longtime plumber or an HVAC specialist that you have a fond relationship with and they install heat pumps, you are more than welcome to work with them. They do just need to adhere to the program requirements in terms of installing equipment that qualifies based on its efficiency stats, and also submitting for pre-install approval and post-install approval. But if you don't, if you're not bound to someone or have someone that you would like to work with already, the participating contractor list is a great place to look. We've vetted all of these contractors. They've provided us references and credentials that we've checked, so we know that they're qualified. A lot of them have done a large number of installs in Middleborough and Lakeville previously. On the participating contractor list, you can actually filter it down based on the type of system that you're trying to install. And you can also see where the contractor is located. So for example, if you're looking to work with someone who's more local, you'll be able to see which contractors are closest to you.
Okay, thank you. So we spoke to this one a little bit, but this question reads, can heat pumps actually replace an oil heat furnace and heat a home effectively in the winter months? Or would you need a backup heat resource during very cold periods?
Yeah, I'll take that one. So it really does depend on the load of the home. So say if there is a centralized oil-fired furnace down in the basement, and let's just say hypothetically, the house is a 2-story colonial, and there is a heat load of 80,000 BTUs per hour. The largest centralized cold climate ducted heat pump is around 55,000 BTUs. So there's a difference with what the home needs and what that heat pump can put out. So there's 2 thoughts to this. Thought number 1 is kind of thinking back of that curve of how many hours do we spend in these coldest of cold days, like the design temperature. And it's only, it's 10% or 15% of the hours of the winter. So you could be making up that delta with installing an electric heat kit on top of the heat pump. So the heat pump's still spitting out 55,000 BTUs per hour. And then that electric heat kit could be putting out potentially 25,000 additional BTUs per hour on the coldest of cold days, or anytime that it's below 20 degrees or 15 degrees. It really depends on the home. The other thought about going that route with sticking with one centralized one with an electric heat kit is that home, as I talked about at the beginning, is not always going to need 80,000 BTUs per hour. So when you do reside the home, that's an opportunity to strip the siding, putting on a fully adhered weather-resistant barrier, putting on an inch of exterior insulation, and then residing the home. Now you've just dropped the heat load by 20,000 BTUs or 15,000 BTUs. And then when you replace your windows and you put in the new generation of triple pane windows, there's another chunk off. And so that way, then it's you're putting in a right size heat pump for kind of the home's decarbonization, energy efficiency milestones, and everything will eventually line up. The other thought regarding this is, instead of putting in, say, one 55,000 BTU heat pump down in the basement with an electric heat kit on top of it, another option could be, let's properly zone the home. So we'll put in one 40,000 BTU heat pump down in the basement and one 40,000 BTU heat pump up in the attic. Now the first floor has its own thermostat and zone and climate control, and the second floor has its own thermostat and climate control. And then you just are sealing off the registers on the floor for the second floor and then dropping down from the ceiling. So there's a handful of different ways to kind of go about it. Or the other combination too is you're just putting in a centralized heat pump. And if you were having some comfort issues with your duct distribution in other parts of the home, you could also solve those ones with ductless, and then you're kind of combining the capacity of the ductless equipment plus the ducted equipment to meet 100% of the building's load. So it's dependent on the home, but yeah, the hearing about that setup isn't any cause of concern to me at the moment.
Okay, thank you. There are quite a few repeats, but I see a couple that we haven't gotten to yet. What's the typical length of installation?
Yeah, it depends. It depends on the scope of the project. So if someone's just looking to put in a single ductless mini split in a great room, that's likely a one-day job. For my own home, it was a full week of, you know, two guys working 8 hours a day, putting in six mini splits and six mini splits and 3 outdoor units. So yeah, I'd say for most whole home jobs, it's likely a week. If you're just putting in a mini split or two, then 1 or 2 days.
Okay. And what's the price range for an installation?
Yeah, and this goes back to those 3 different scenarios with the same home but different equipment setup. So it is a little hard to say how much this will cost you. But typically when I'm seeing a mini split, I'm seeing those coming in somewhere around $5,000 per unit. So if someone's thinking that they need 4 mini splits, I'm thinking instantly that this job is going to cost somewhere around $20,000. I see 4 mini splits getting installed for $15,000 still in 2022. And I also see 4 mini splits being sold and installed for $25,000. So there is like a lot of variables with getting quotes and what people are wanting to charge. For ducted equipment, typically, if you have existing ductwork, then maybe that's going to be like closer to the $15,000 to $20,000 when you are pulling out a full furnace and putting in a heat pump. But if you are needing brand new ductwork in conjunction with a brand new central heat pump, we see those coming in somewhere closer to like $17,000 to $25,000 for a whole home. So it's all over the map. But with a lot of homes, with having a budget in mind, usually there's a pretty good, there's usually a heat pump designed to meet within most budgets. And the other thing that I will say about cost is I always remind people that we have 2030 climate goals and not necessarily 2022 climate goals. Like maybe middle of our gas and electric department has 2022 climate goals, but there is nothing wrong with taking this in stages. So say stage number 1, if you install a smaller heat pump system, that's probably all the heat that you'll need in the spring, the fall, and 100% of the cooling that you'll need in the summer. And then phase 2 of the project could be then meeting kind of the rest of the home's load. And typically 2 smaller size systems works more efficiently than 1 huge system outside. So the smaller size systems are a bit more efficient. They're a bit more flexible on kind of the more moderate days as well. So there's nothing wrong with kind of starting small and building up from there.
Okay, thank you. And then the last one, there are some more specific questions that we received. So I think what we'll do is reach out to those customers individually to try to give them an answer to those. So the last general question we have is, what is the effective life of the unit before having to be replaced?
Could you say that one more time, Kyle?
Yep, I think I beeped in the middle of that.
What did he swore?
No. What is the effective life of a unit before having to be replaced?
Yeah, it's true for pretty much every high efficient heating system. So any condensing gas furnaces, condensing gas boilers, heat pumps, I would just plan 15 to 20 years is kind of the useful life of it. There's certainly equipment that will last longer, and there could certainly be lemons, but the manufacturer's warranty is 12 years. With like Mitsubishi, it's 12 years. With Fujitsu, with LG, it's 10 years. So yeah, so you get a decade of, complete peace of mind, but will it last a decade longer than that? As long as you keep it properly serviced, it's, it really is just an appliance at the end of the day. So 15, 20 years. And if you ask me how long an on-demand hot water heater would last, same thing, 15, 20 years, kind of the days of a heating system lasting 50 or 100 years when they're just these like cast iron school bus size contraptions made of steel. Those are long gone. So yeah, there's a lot of fine engineering, finely milled metal inside of there. And it is exposed to 4 seasons of New England. So yeah, it is a bit of an investment, and it will need to be replaced at some point down the line, but 15 or 20 years of expected life.
Okay, perfect. So I think that just about wraps it up. If anyone has any last minute questions, could you please put them in the chat now? So we'll give about 45 seconds, I think. Just in case anyone has something they really need to know. And if not, I'd just like to thank everybody again. Thank you, Mike and Ryan, for joining us tonight. We really appreciate it. And hopefully we were able to answer any questions people had regarding this technology.
Thanks everyone for attending.
Thank you all.